And in this video, you can actually follow me along. You need to have Docker running on your computer. So in this case, I'm going to run my Docker desktop. So that's going to actually run Docker. And another thing that you want to do is basically check the version of your Kubernetes Kubectl command line tool. But if you have not installed it, please go ahead and install it. If you're on Mac, you can just say brew install and then Kubectl, okay? So mine is not updated for quite some time, so I could actually do while I talk about other things, all right? So this is a version already installed and it's not just linked, so I'm gonna link it. What is the issue? It's already existed. And if you want to do the force override, actually I could do so. It's because during the installation process I canceled it. This is why it caused a bit of issues. But anyway, so if you can run kubectl and then version command, you would be able to see stuff, right? So exactly you can see I have got this client version 128.4. What is Minikube? Minikube is basically local Kubernetes environment tool, meaning that is similar like K3D, Kind, K3S, tools like that. So it's basically meant to be helping you for your local development of your Kubernetes application, okay? So it's basically the tool that comes with Kubernetes, right? And you could basically create cluster, you could do stuff, and you can deploy your application in there. So on your local computer, you could basically deploy your application. So that's what is Minikube is for, okay? And how to install it? So the easiest way actually you can do Minikube is this way. Pre-install Minikube. So it's going to install Minikube on my local computer, okay? So as you can see, Minikube has been installed and I'm going to show you actually documentation. So it's going to be very easy for you to follow along. And there is another video. I'm going to talk about it after some time. So here is the Minikube documentation. Don't worry about it. I will share you the documentation later on in the video description. All right. So it's a tool for local Kubernetes. So it's basically you could develop your Kubernetes application, right? And there are two things you could do. You could run with Docker or you can run with virtual machine like Oracle VirtualBox or similar, okay? But in this video, I'm going to use Docker Desktop. And as I say, I have got Docker Desktop running on my computer. So if you can see, this is the application I have. All right, Docker version command, li command basically anyway. So this is the Docker version. As you can see, I'm running right now. And if you haven't installed, you can just go ahead and install Docker Desktop on your computer. Anyway, so that is that. And now we're gonna look into this installation for the people who don't have Mac actually. So how are we gonna do that? You basically copy this installation script so you can see how to do it and install it, right? And if you're on Windows, you go ahead with the Windows. If you're on Mac OS, you can go with Mac OS. If you're on Linux or different architecture, you can go ahead with any of those that is suitable for you, okay? Once you have the installation, you could actually go ahead and start working with Minikube. So before we do anything, we want to do a bit of Minikube stuff. So how to do that? So let's see. This is what happens basically once you type in Minikube. And this is really good to get actually familiarize yourself with the tool that you are going to use. This is similar to K3D that I did some time ago. So they are talking about, you can say, if you're trying to run this on this, then like M1 chip, then you basically do this. So I'm not going to go ahead with that at this point. So what are you gonna do? How do you start a local Kubernetes cluster? This is why I talked about this video. Here I go through pretty much details with K3D. So these are like similar, but just the different tools, just to let you know. So in this case, what I'm gonna do, I'm gonna walk you through quickly what are the things actually available with this tool, right? It's also good to know basically what kind of options you have, what you could do technically with Minikube. So if you type in, so here you can see the version I'm running is this, and this is the hash of that particular version. The other thing that you would be interested to see is basically pausing a Kubernetes cluster. You can unpause a Kubernetes cluster. You can go ahead with the dashboard. You can delete a Kubernetes cluster. You can stop, right? So there are quite a lot of things you could do. Could be interesting also for you if you want to run with Docker or Podman, for example. So Podman doesn't require a daemon. The other thing you would be interested in to look into add-ons, config, and most likely the dashboard. So I'm gonna go ahead actually and show you the stuff in a bit, okay? So now we're gonna basically see what we have in our Kubernetes cluster, right? We don't literally have anything. We have not created any cluster literally. So we'll create Kubernetes cluster, as I said right here. How to install Minikube, we have seen how to install it, and then we want to create a cluster, and after that we want to basically deploy our dummy application to the cluster. Okay, so without further ado, let's get started. So I'm gonna start with Minikube, and anything you wanna do with this, you can also run this command like options Minikube, and these are like basically the global commands, right? So just to let you know, to have Docker, I have got Docker, right? Alright, so you can see the Docker is actually running on my computer. So I'm gonna say Minikube and then start. And as I said, virtual machine and Docker containerized environment, you can do both. So if you say driver Docker is gonna actually start the cluster with Docker. So in this case, I'm starting a Kubernetes cluster that is going to be running on Docker. Okay, so this is going to be running on Docker. So you need to say driver Docker, and I'm gonna take you to the documentation also to show you this is how you're gonna do. And if you want to set it by default, you are going to run this command. So minikube config set driver Docker. So once you finished running this stuff, okay, so these changes will affect upon a Kubernetes delete and then a Kubernetes start. So we are basically good at this point. I'm gonna name my cluster, let's say dab. If you do not say anything, then cluster name is going to be Minikube, okay? So this is fine at this point. CPUs is going to be 2 CPUs, this is the minimum requirement, and the memory is going to be, let's say, 1800 MB. And the other thing I want to do, I want to say, hey, Kubernetes version I want to run basically is this v1.28.1. This is the version I want to run. What this command is going to do is basically create a Kubernetes cluster, and I'm actually using Docker, right? For each node, I'm actually allocating 2 CPUs and 1800 for the memory, okay, 1800 MB. So let's get started. Once I enter, I'm going to make it a little bit bigger. Creating Docker container. If you are really worried about whether you should run it not as root, you can actually run Docker as rootless, or you can run Podman actually on your local computer. But for me, I'm not too much worried at this point. Okay, our cluster is created. So Minikube status, if you run this command, and this is the control plane, meaning that this is the master node. This is the master node. And this is my worker node. Okay, so I have 2 node Kubernetes cluster. One is serving as worker node, the other one is serving as the master node. So we're gonna run kubectl get nodes, and here you can see the version of our Kubernetes cluster, right? And if you wanna see a little bit more, you can just expand it like so. So this is what going to tell you a little bit more. So this particular node is running on Ubuntu. This is the version. This is the kernel version, as you can see. And here is the Docker version, right? Excellent. And right now, if you see kubectl, there is nothing running. So I talked about the namespaces before. I'm gonna show you still, if you're new to my channel, there are like 4 namespaces created by default. Okay, so here is the IP address for this particular node. And this is the IP address you can see for this master node. If you run this command kubectl let's get SBC, which is service, when you create a Kubernetes cluster, it creates a service called Kubernetes, and it has a cluster IP type. This is a virtual IP. This is being taken care by kube proxy actually, and it has no external IP, right? So I could just say Minikube, but when you create a cluster, this is similar to K3D. It automatically switches the context, meaning that this is the context in this case, which is this Minikube cluster. So it automatically does it for you. So you don't have to do anything. So if I have done this, so it's going to switch to the context. I could do also with kubectx. That's more easy. So if I'm doing kubectx, it's going to do the same thing. And you can see it's highlighting this one, meaning that this is the current context at this point. So the first one is checked. We created a cluster, and the cluster actually has, so if we run this Minikube IP, it's gonna give you the IP, right? So the master node IP basically. So let's jump into this one, deploy a simple application. So let's go ahead and see. Now you see it's actually pretty quick. So our deployment is in there. You try to see the pod, get pods. You can see the pod is running. So one thing you want to see is basically where this particular pod is actually scheduled. So if you look at here, this is the worker node, right? And this pod has an IP address. This is a VIP, basically a virtual IP that kube proxy. The second thing, what we want to do, we want to see replica set. So you can see two replica set is basically we are saying that okay, current is actually 2 pods are running, right? And 2 is actually desired because we said, hey replica, you give me 2 replicas, run 2 replicas at all time, right? So this is what exactly is doing. Next one we want to see is this one. EP command is basically the endpoint command. So at this point you don't see actually nothing other than Kubernetes because we have not created any service for it. So let's jump into this part. So we created, basically, we deployed the application to our Kubernetes cluster, but this service is not actually exposed to anywhere. So what we're gonna do this time, we're gonna expose our service. To expose this, we're gonna run this command, expose and deployment. Remember, if you are not putting the name demo, it's not gonna work. It's because I talked about the label, right? And this label, I'm going to show it to you first. Maybe this is something very important. Talking about pod. Pod is which one? Demo, right? Oops. Oh yeah, doesn't matter because it was starting with the demo. So if you look at here, it has a label demo. Service discovery has a selector which will be actually exactly the same name. So the service actually can discover which pod it has to send the traffic, right? One thing here is important. Is basically talk about it after some seconds because I will talk about it after some seconds, not now. Okay, let's talk about this. So you're gonna expose the service. So you're gonna say kubectl expose deployment demo. You have to have the same name. What you have in the label is because we are using the CLI, right? So we need to make sure that the service can be exposed on a particular port. So this is the one we are going to be using. So you can say type like cluster IP. This is the default one. If you don't set, it's absolutely fine. So if you put it, it's okay. If you don't put it, that's also fine. The port is going to be what? 8080. This is the port we are going to expose to. So basically our service, which will be called demo, is going to be exposed to this port. Okay, so let's say kubectl get SBC. So this time you can see a service is actually created, doesn't have an external IP, it has a cluster IP. We'll talk about it. And then the service is exposed on this particular port. Okay, now what happens if you want to actually access this service from your browser? So let's say you went to your browser. So if you go here, On your browser, you cannot. It's because when you say cluster IP, your cluster is not accessible from outside the cluster. Meaning that now I'm in my browser, right? And Kubernetes is running on Docker containers, right? The entire Minikube cluster is running on Docker container. So this Docker container or the Kubernetes cluster is not exposed outside of this cluster. So right now I'm on my local host trying to access Kubernetes and it doesn't know how to reach it, right? So this is what you need to keep in mind. What we're gonna run a command called minikube service and then list. Here you can see we have a service called demo. These two you don't have to care at this point, just focus on this one. Okay, there is a way actually to access the service if we do a port forwarding. So actually we expose the service, this one we mark, and we actually did scale replicas to 2 or more, right? We did that. So the next one I'm going to show you is this one, minikube service, and this service we called demo, right? And if I enter now, this is minikube specific, remember this guys. I'm actually able to access the service. And if you look at to the URL, you can see it's not 8080, it is 54097, right? I will make it bigger for you. So this is the response we get back. And this is the one you see is the pod, basically name of the pod, okay? So if you go here and type in, let's say, kubectl get ports wide, it's like sk, right? So you can say msk, right? This request is actually handled by this particular pod. Remember one thing, Minikube, what it did behind the hood, it basically created a tunnel so that the traffic from this computer can be forwarded to your Kubernetes cluster. So meaning that to your service and service to your pods. The to and from communication is actually established by a Kubernetes via Minikube tunnel. So Minikube actually doing the networking part here, okay? So what happens if I actually, let me show you, what happens if I kill this? Remember here, if I kill this, I would not be able to access this service, right? Right away, you can see you can't access it. So what I'm trying to say is that if you have a cluster IP type, you cannot access your cluster from outside the cluster, okay? Another way I would be talking about, so it's basically kubectl port forward, and you want to port forward to 127.0.0.1 to this IP. So basically I'm talking about my Mac, right? And to this port, let's say. So you want to actually forward the traffic. So it's basically, this is the endpoint, right? So if I'm going to this one and trying to reload, it's actually able to access my Kubernetes cluster. It's because this time we are doing a port forward. What is port forward? It's nothing but forwarding this traffic from my local computer to all the way to Kubernetes cluster. When we run this command, if you remember, when we executed this command, right here, it was here, executed this command, Minikube randomly picked up a port number, right? When we run the command of port forward, we specified, okay, this is the port this service should be listening to, right? So this is what exactly is happening. So this is also port forward, and behind the hood, Minikube actually did the port forwarding right here. So it's basically forwarding the traffic from, to and from your Kubernetes cluster. So this is one way of accessing your service. Alright, so if I kill this, it means that I am not actually able to access my service. Now, I'm going to show you what happened. If I go to node list, I can see the IP address of this particular node. IP address of, this is the internal IP of this node, remember, okay? Alright, we talked about port forward, and I'm going to actually show you demo for the cluster IP. So I'm going to deep dive a bit more for you guys. So if I'm running this command, kubectl get EP, now this time it's actually giving you endpoints. So basically your service, this is basically the IP address of your pod. So if I'm running this command, because we have two ports, right? If you look at here, oh yeah, we need to actually run this command. You can see IP address of one port is 10 dot blah blah 03 and the other one has 1.3. So this is the worker node, right? Worker node. And 8080, remember, we exposed our service. So basically the pod is actually serving or listening on this particular port, right, to serve our service. So pod is basically running the service on this particular port, right? Excellent. What we're gonna do now, if I do a curl from my computer, you know it's not gonna work. So 127.0.0.1 and then 88, it's not gonna work because it's not listening on my local host. It's listening on the pod which has a particular IP, and this is where we can access it. So now I'm going to actually SSH Minikube node list, and this time I'm gonna do Minikube SSH. So if you do not say node, like this is N means node in short. If I don't say like Minikube M02 whatever, hard to pronounce. If I do not pass anything, then it is going to actually SSH to my master node. So let's see. So this is how you SSH. So if I'm saying this, then I get the IP address, right? So if you have noticed, Minikube, hostname, this, I get the IP address, right? The IP address of which one? This is the IP address of the node, not the port. We are not talking about. This time, if I'm running this command called kubectl get ep, this is where our service is exposed. And if I'm doing a curl right now, so I'm inside the node, and you can see I get a response back, right? So if I'm doing curl minus I and then curl minus capital I, and then I basically take this, I'm gonna get also a status code, you can see, right? We can access this. So here is still within the cluster. So what happens if I go to the second, and if you try this, let me do the same. If I try this, actually I can, right? Now we talked about this kubectl get service, and we have this service called demo. So kubectl describe service, and we want to describe this demo. And notice here is the endpoints. Service actually knows which pod to talk, right? Is because service has this selector called app demo, because the selector is basically to filter out the objects. So in Kubernetes context, pod is an object, for example. So when request comes in from my browser, from anywhere, it basically knows how to forward this traffic to its backend pod, basically, right? So this is how actually service does a discovery. Okay, so the second thing we want to look into, I need to go back here. So kubectl get, as we see, cluster IP. So this time you can see cluster IP in listening on this particular port. So if I'm doing this with 8080, I should be able to access it. So you can see cluster IP has exposed its service, right, on this particular port. So what we have learned. So this is a node. From this node, I could basically access my service. My service is running basically on those two ports, right? And remember, the other pod is basically running on the other node. So if you ping from this node to another node, they will be able to talk, right? So the communication is basically taken care by kube, the cluster IP type that we talked about, the service type. It does the communication. So now if I'm going back and I say Minikube node list, this time I'm gonna do Minikube SSH, and this time going to be SSHing to this particular node. And here, let me go back again and copy this stuff. If I'm doing this one, and this, I'm able to actually access my service, right? Similarly, if I'm doing the same to, if I'm to the same to these endpoints, I would be still able to access my service. So what I'm trying to say is that from within the cluster, you can actually access the service. But this time, if I'm right now, I'm in the node, right? Oh, by the way, let me show you. Curl minus I, right? This time, if you are trying to do like, you might have the question, oh, you were able to, what about the localhost? Because you were inside the cluster. So basically, we are on the second node. So what happens if I try to curl? It's not going to work. It's because we are actually trying to access this service on this particular node, right? On this particular port. But this is why our service actually is not running, because service is running in this node. If you might have guessed the answer already, right? In this node, in the pod. Pod is hosted right here. So remember this. This is why it doesn't work, right? So what happens if you try to access the other pod? Actually, you would be still able to do so. So if I'm doing this, curl this, and then 8080, I should be able to access it. So this is what is cluster IP. What does it mean? So basically, from within the cluster, you can access your service. You cannot access your service outside of the cluster. So now what we have learned, basically, what cluster IP does, right? And when should we actually use it? So for example, if you want to expose your service to the public, you need to use the load balancer. So we're gonna continue where we left off. So kubectl, my hands are literally frozen, it's too cold. So okay, we have two demo ports where our kick-based application is deployed, right? And it's running currently in there. So if I run kubectl rollout, and you could do a couple of things. You always do the tabs right on your computer, and you can say deploy meant and the name of the deployment. So here you can see it was successfully rolled out. So if you want to see the history, so you could actually see the history, and you can always type in the deployment, for example, demo. So this is going to be showing you basically the version, right? So if you wanted to fall back to, let's say, if we had 1 to 5 version, or you can call it revision, I'm calling version at this point, is the same thing. So technically you could fall back to revision number 1, revision number 2, 3, or whatever, right? From the latest deployment. So since we don't have any changes, we are not going to show you that in this video, maybe in the future videos, but I just wanted to let you know this is how you could do stuff. The other thing actually I want to look into is get SVC. And in the SVC, we had the cluster type, right? So if I wanted to convert this one to node port, either you delete this one and create the service again, or you could actually convert it, meaning that you could convert from cluster IP to node port and everything else remain the same. Okay, so to do that, I'm gonna copy this command. I have it already here and paste it right here. So here what we could do, we could basically patch the type from cluster IP type to node port. So if you have noticed kubectl get SVC, this has been actually changed to node port. And one thing that you have seen different right now is this part. Before, when we had cluster IP, you can see we had 8080, nothing else was there. So now we have this node port IP. So what happens when you change to node port and you do not specify the port number? So Kubernetes will assign a port 767 in this range randomly, okay, for you. If you do not specify what would be the node port for this one. So this is how it actually works, okay, just to let you know. So this is what we have. And when you have node port, doesn't mean that I would be actually able to curl to my local host on this particular endpoint. Actually you can't, right? And if I change this one to 30611, look at this, you cannot. It's because this service is not exposed on your computer. So we are talking about the internal IP of our computer, right? So you can actually access it using port forward. Okay, it's not there, so I have to write the command. So port forward, I'm gonna show you the picture in a second what this node port means, just in a second. So port forward to what? So we can say 127.0.0.1, and then from there is basically service is demo. You can actually put forward to this, right? So if I am going here and I'm saying curl, and then you just type in 127.0.0.1 and 8080, I should expect the response back, right? So you can see MSK is basically the pod. So I can just show you kubectl get pods. So MSK, you can see. So this pod is actually handling the request, right? Excellent. So you can see if you do the put forward, you can access it. The other way you could do, I talked about this in the previous video, but still I'm gonna show it to you if you're new to my channel, okay? So here you could actually do this Minikube service and demo. This is also actually doing the traffic routing from my computer to all the way to Kubernetes cluster. So now he's gonna go to DuckDuckGo, which is my default browser, and here you can see I'm able to access the service, right? So if I'm killing these, now I would not be able to access it anymore if I reload the page, for example. So notice this is here is a port that is actually randomly chosen by Minikube, right? So this is also the same thing like port forwarding. They do the tunneling and takes care of the networking part. So this is what we discussed in the previous video as well, right here. So here we did the recap and we exposed the service using node port. So now we want to understand, we talked about the port forwarding as well. Now we want to understand how does node port actually differs, right? This is what is the part you want to understand, differ from cluster IP. What is the difference between the two? I want to go back to this picture, writing that I have here. So here the cluster IP means that from within the cluster you can access your service. That's what it all means. You cannot from my computer access the service unless you do some port forwarding or some tunneling, like some kind of networking you have established, by which you can actually talk from my computer to all the way to Kubernetes pods, okay? Because if you have noticed, Kubernetes pods actually running on a different network, right? So how do you know? It's kubectl get pods, and if I do this, I know this network is different from my computer network. So what I wanted to show you, this is basically a different IP address than the one my computer. So it's running on 192.68. blah blah, right? So they don't know how to talk to each other. There is no networking established. When you actually do the node type, what is going to happen is that this functionality, the cluster IP functionality, is going to be embedded or going to be baked in to node port type already. In addition, what you could do is basically is going to expose the service. We are talking about the node ports. So node ports are basically the cluster nodes. So we are talking about this node. So Minikube node list, we have two nodes, right? So we are talking about these two nodes, right? And then the particular port. So there we would be able to access. If you have not understood yet, you would understand in a second. I have a picture for you. Cluster IP and node port. Now I wanted to show you this image. Right. So I want to show you this image. This is copied from the internet. I didn't want to actually make the image for you guys, but I was thinking I could really explain to you what this means. So side by side, let me explain to you what they mean. If you look at this, you can see this part is basically same in here, right? So traffic comes in and then traffic goes to SVC. SVC does the service discovery and is going to forward the traffic to its backend ports, right? That's how the service request is basically handled. So directly in our case, service was what? Service was basically those endpoints, right? Right here, if you look here, we are talking about the service, but this time we have the node. So we are talking about primary or worker node, doesn't really matter. So I'm talking about this node. So Minikube node. So this time, actually we are accessing the service on its IP address in this particular port, meaning that here our service is actually exposed. But in here, that is not the case. In here, you would not be able to do so. From this computer, I'm actually curling this endpoint, which is basically the other computer, right? And here on its own server where service is running, we are able to actually access it. But in terms of cluster IP, this is not the case. We can only access the cluster from within the cluster, but here is actually accessing the service. You can say exposing the service, the external expose, you can say in this way. Because let's say if someone, let's say there is a computer number 4 with the IP address or 10, let's say your friend is using, but who is not part of the Kubernetes cluster, right? Meaning that these two computers are part of Kubernetes cluster. So if someone else in my private network, right, go to his browser and type in, he would be able to access it. So this is why service is actually exposed outside of the cluster. Remember, because now what we are doing, we are actually accessing the service from within the cluster. Is because I actually SSH'd to this part, right? But if someone, let's say your friend has a computer connecting to the same network, what he's gonna do, he's gonna type your IP address, private IP address, right? He would be still able to ping, and he's gonna say 30611, and he will be able to access your service. So that's the core difference between the two. In the next video, I'll be talking about load balancer. If I do Minikube SSH, I'm going to SSH to my master node. Okay, so here you can see hostname, my hands are frozen, I can't really type. So you can see the IP address is basically this one. So what I mean, so now if I curl, before I do the curl, I need to know this one. So kubectl get endpoint. So I know this is the endpoint where my service is basically exposed, right? So if I go here and I curl, we should be able to access it. So this is number 1 port, right? And the other port is basically having this particular endpoint, right? Exposing the service in there. So if I'm now saying curl this, so we are actually able to access our service, right? So, and then the other thing we could do is basically the cluster IP. So I have to go kubectl, oh no, I don't have to type it as we see. So if I'm doing this, you can see cluster IP. This is where my service is also exposed, right? You can see. So this is what by the cluster IP you can do. So now the only difference actually it makes now is this node IP. Talking about node IP of this computer. Node IP of this computer is what? Let's say this, right? So this, what I'm gonna do, I'm gonna say curl, and this time I'm gonna say host name. My hands are completely frozen. And here this time, if you are following me along in this video, what is happening here is basically this is the port where the service is actually exported on the node port. So node port is basically we are talking about the IP address of this computer. Before we were not able to actually access it with cluster IP, right? So here if so let me see what was the port number. 3611. So 3611. If I'm doing this, actually you can see I'm able to access the service. Before we were not able to access with the cluster IP. So now if I go to the other computer, IP address of the other computer. So Minikube node list, and we know that this is the IP address of the other computer. So if I am trying to curl and this one, and I know the port number 611, look at this. We are from this node, actually we can access the service which is exposed on the other node. So that's the difference, meaning that node port means on a specific IP address, right? On a specific port, your service is exposed, and this node is part of your cluster, right? So in our case, one node is basically we talked about it, we are repeating ourselves right here. So one node is basically, this is the control plane node, which is basically the Minikube, is named Minikube, and the other one is basically called M02, is working as a worker node. So first of all, let's understand how this actually works. So I have a picture. This picture I copied from the internet. Disclaimer, it's not my own picture. But in the picture we have 3 pods. But don't worry about it, I'm going to explain to you. So what it means, traffic. Traffic means, let's say you are on your browser, or let's say you execute a curl command. You go to your browser. So when I go to my browser, abc.com, I first actually hit the load balancer. In the public cloud, you might be using already application load balancer, right? There are like application and network load balancer, but I'm talking about layer 7 one. So HTTP, HTTPS. You get the load balancer. So load balancer basically first get the request and right here. So when you go to abc.com, load balancer is going to get your request and then it's gonna forward the traffic all the way to its backend depending on how actually you have designed your system. Here you might have ingress controller, right? You might have, in my previous video I talked about it in K3D videos, right? Here you might have, let's say Nginx or Traffic or MetalLB, such kinds of reverse proxy, right? That actually forwards the traffic to SVC. So the SVC we are talking about is the Kubernetes Service Discovery, right? So this one is going to be receiving the request and it does the service discovery and going to send the request to its backend pod, and this pod is going to be, giving you the response back. So all the way it goes to load balancer, and this is what happens. abc.com, I get this page basically to get to see the home page. If you look at here, let's say this pod is actually running in node 1. So we are talking about node list. So basically, let's say the Minikube node. So we are talking about this one Minikube, right? Let's say this pod is running in this node, and then we have the second, let me select it. Then we have the second pod, which is running on the worker node, right? So it's node number 2. When we try to curl from our computer, let's say I'm on my local computer, right? We could not actually access the service. Is because in the node port type, the service was exposed to a particular node, right? So I'm talking about the nodes in the cluster, right? My computer is not part of the Kubernetes cluster because my computer is outside of the cluster. It's because they are running in Docker, right? From my computer, if I do a curl and then I say 127, or let's call it localhost, something like this, localhost, and if it is exposed to 8080, I would be able to access my service, the key-based service. But in the node port type, this is something we couldn't do, right? Without the port forwarding or without using the kube tunnel. But in here, you would be able to do so using load balancer type, meaning that you would be able to access your service from within the cluster and outside the cluster. If you have a public IP address and your friend actually goes to your browser, let's say you live in Europe, your friend lives in Mexico, he just goes to his browser, right, and types the IP address or the DNS, right, of your service, he would be able to access your service, right, unless you block his IP addresses. There is like geographical restrictions. Let's not focus on there. Then he would be able to access, meaning that your service is basically public. Anyone can access your service from anywhere. But in node port type, you can't really do it. You could actually access your service from node number 1. This is like, let's say, primary node, and here is the worker node. From here, you could do the curl, right? And if you have a browser, for example, you could also access it from there, right? And if you're on the same network with the cluster IP, you could actually access it, right, within the cluster. With the load balancer, what happens? You make your application public, meaning that your application is exposed to a particular IP address where on a particular port, let's say port 80 in this case, so you can actually access it. So this is the load balancer type. And if you don't know what is load balancer basically does the distribution of your traffic. So if request number 1 comes in, does round robin. So it's gonna send it to here, the first request. If the second request comes in, it's gonna actually send it to the node number 2, right, in here. And then if the third one comes, it's gonna go here, fourth one goes here. So this is like one of the duties load balancer does apart from many other duties. So this is what is load balancer. Service is basically doing the service discovery. So it's going to basically trying to figure out which pod actually to talk to within the cluster to get the response back, right? So this is what service discovery does. So as we talked about, it does the filtering. We talked about label. We talked about select. In ingress controller, this is what exactly is going to be happening. So ingress controller is going to check which service actually has a match with the label, right? That's why we are also using label in here. Okay, so this is basically the concept, meaning that if someone goes to his browser, he can access your service. But in our case, in today's video, we do not have a public IP address. We have our local host. And when I show you the demo, this is what I'm going to be using. Since I don't have a public address, I can't unfortunately show. show it to you, but what I mean is that your service you can access from anywhere. So this is the background behind it. I hope you understand. If not, there is no problem. You can just follow me along. So when we talk about load balancer, basically it does the load balancing, right? It basically distributes traffic across your devices or across your server fleets, right? Okay, so that's that for the theory. So let's jump into the actual demo. So what I said is basically you can access your service from anywhere, right? And in here, I will mark this one. This was a recap. If you remember my patch command that I used in my previous video, instead of node port, what I'm gonna do right now is basically the load balancer. So I'm gonna use load balancer. So if I'm using these, I would be able to see that type is actually changed to load balancer. And in Minikube, you see the IP address class or IP address would not change. It will remain as it is, right? This is the virtual IP that is actually created by kubeproxy. And if you have noticed, the IP address of my computer is basically 192.168 dot blah blah blah, and the kubeproxy actually creates on this network, right? As you can see it. So the external IP you can see is pending, and there is a reason why this is actually pending is because of this. So you have to do this Minikube add-on and then list. Here you will see one service called ingress. This is right now disabled, and this service you actually need to enable. These add-ons basically are plugins. We don't need the DNS at this point, but we can use the ingress add-on. So what I'm gonna do, I'm gonna say let me clear this, and I'm gonna say Minikube add-on, and then you have to say enable if you want to enable, and if you want to disable, you just say disable, right? Like that, just like that. So enable, and I want to actually enable ingress. So if you are doing this, it's going to enable the ingress. And this is the interesting part. You need to be very, very careful about this. After the add-on is enabled, you need to actually do a kubectl. Otherwise, if you go to a browser and you type like, let me open this one. If I go to localhost, let's say our service is exposed on this, it's not gonna work. And we have this example right here. You would understand in a second. So let's see Minikube add-ons list. Let me grab and see the ingress is actually enabled. So you can see they use emoji. You can see. So it has been enabled. Then what I'm gonna show you right now is SBC. And if you look at here, it says pending. It is going to be pending as long as you do not run this command called tunnel. And after I do that, it's going to actually fetch the IP address. Since we do not have public IP address, therefore it's going to be localhost. And let's actually see it in action. So when I have actually done this, it actually started the tunnel, as you can see, right? And this is something, if you close this terminal, it's gonna kill the process, right? So meaning that you would not be able to access the service. Now if I go here, I would be able to access let me make it bigger. So you can see if I do one more time, it's actually, let me see. Okay, our service is basically here. As we see, you can see the external IP is already given, which is our localhost basically at this point, because I do not have the public IP address. So now if I say Minikube node list and I say SSH, right, and I say curl localhost, and our service is exposed in here, and now we can actually access it. In node port type, this was not possible. We could actually basically curl to the IP address of this particular node, right, on a particular 30,000 something, right, node port. Now you can actually access it. So if I go to the second node and Minikube node list and Minikube SSH, and node is going to be Minikube, there is no auto completion for it. Okay, so I could just copy and paste, and if I'm doing this and I'm saying that localhost 8080 actually I'm able to access my service. So if you have noticed before, in cluster IP type, neither in node port type, we were not actually able to access the service, but in load balancer type we can actually access it. One thing I wanted to show you now, if I kill this, if you try one more time, you would not be actually able to do so. In Minikube, this is how it works, right? So if you want to access it, make sure that you need to actually start the tunnel. And the other important thing you also want to see is basically this This is also good to know. If you are doing this, basically, let me do the list, right? Not this one, add-ons. Let me go to add-on, Minikube, add-on list. If you actually enable, because we enable this, right? And if we disable right now, it's gonna fall back to the pending status again, right? So I'm talking about this one. It will actually fall back to pending. Look what has happened right now. Look at this, because we kill the tunnel. So remember this, if you kill the tunnel, this is what you're gonna see. You do not have to disable this service. You can see right away there is a change, right? So if you want to see the IP address of this is something you need to do. So if I'm doing it one more time and then I run this command called get SVC, I would be able to see this. Look at this. And if I'm trying to curl this, which is what already we are doing from our browser, we are actually able to access the service. So this is the difference. And if you have noticed already, we have got two ports, right? Because we have the 8 a.m., right? We have 8 a.m. This port is actually serving our request. And now if I do one more time, let's say I do this. This is what also good to know. You see, the next one is going to MSK. So this one was to this one, right? The request was sent, and the second one actually was served by this one. So you can see load balancer actually, distributing the traffic, right? So this is what load balancer does. So what happens if I actually try to talk to Mongo? So let's say I have got Mongo SH. You need to install this if you do not have it installed. So this time, if you see, the service is actually listening on port 7000 on my local computer. So this time I'm going to talk to Mongo, and straight you can see I can access the service without going into the Kubernetes cluster. I'm actually able to access MongoDB. You can see MongoDB, which is running within my Kubernetes cluster because I have the port forwarded, right? So now as long as this is open, you can talk to. So this is a temporary connection opening, as you can see. So if I close this and I try to do something now here, you can see, so if I say show DBs, this is not gonna work. You see, the connection is interrupted because it doesn't know how to talk to. It means that my computer doesn't know how to talk to your Kubernetes cluster. So now if I am actually running this one more time, and this time actually I say show DBs, you can see it shows the list of DBs that is available. These are basically the by default. If you have seen my previous video of K3D, here I basically explain pretty detailed about service types and things like that. But anyway, today I'm gonna go through them one more time so that you understand the concept pretty well. I have a deployment.yaml file and service.yaml file. So in the deployment.yaml file, disclaimer, I have actually taken this manifest file from this particular location. The only modification I did is basically this part. Anything else is not my work. What it does is basically deploy MongoDB 4.2 version, and this is the port where this service actually is exposed. And I have a service. This is a cluster IP type. As you can see, this is something I modified. You don't really need this line particularly, but still. And this is where this service is basically the service is listening to. You can clone the repo and play with that if you're interested. So without a further ado, let's get started. So kubectl apply -f, and I have this MongoDB. Where is this project actually? So let me see. This is in Kubernetes. Yeah, and then Mongo. And right here I have deployment.yaml. So I'm gonna deploy this. So if I deploy, it's going to create one replica, meaning that one copy of our pod, right? So one pod will be running at all times. Then the second thing I'm going to do is basically this one. So kubectl apply -f, and this is Kubernetes, Mongo, and then service.yaml. So here, what we have done deployment. We did one deployment, right? And then we did create a service. Let me see, I need to get SVC. Okay, I have it. So here you can see the service is actually called Mongo, and this is the cluster IP, and this is the target port as we mentioned right here. if you remember, right? So this is where the service is actually exposed. So what we are gonna do, we're gonna say kubectl get pods, and we can see there is a Mongo pod running. What I'm gonna do right now is basically show you this kubectl get pod and it's Mongo, and I'm going to basically print out the port number where this service is basically listening to. So this is the command I'm going to be running, and this gives me the port number, right? This is where the service is actually running. So right now we know that our service is running, and we're gonna do port forwarding. Why do you actually need port forwarding? What does it actually do? Port forwarding does basically create a tunnel from my computer to all the way to my Kubernetes cluster. So I'm talking about the Minikube cluster. So what it does is basically the following. So let's say if I'm saying kubectl port forward, this is the command we are going to run. Port forward will let you talk from outside of this Kubernetes cluster to a specific pod. So we are talking about this particular Mongo pod where service is actually running. This is why actually I run this command on this particular port. So from our computer, we cannot access this port, right? Because it is not exposed outside of the Kubernetes cluster. So this is what we're gonna do. So we are going to talk or interact from our computer to this Kubernetes pod, which is listening on this particular port. So what I'm gonna do, there are multiple ways actually you can do. Oh, by the way, I need to run this kubectl get rs, basically replica set. You can see one replica is running because we mentioned right here at all times run one replica. So it's actually running. So desired is one, meaning that we are asking for one, and current is one, ready is one. So meaning that we were asking for one pod to run at all times, and it is actually doing that. So everything looks good. So now we can go back, kubectl port forward, and right here what we're gonna do, we're gonna say service. This is what actually I showed in my previous videos. I did not talk about pod deployment replica set, so we're gonna talk about this. So if you are trying to actually do a port forward, you are trying to do a 1-1 mapping. 1-1 mapping means this basically, let's say from my local host, let's say 7,000, from this port I will be trying to talk to this particular port, which is actually the pod. Basically every pod has an IP address in Kubernetes, right? By default is gonna be 10 dot something, right? So whatever IP address of this pod, you can actually see it right here. So here, right here, you can see the Mongo is basically exposed. This is the endpoint, right? So 10 dot something. So let's say this is the one. So what it is trying to do, the port forwarding I'm trying to explain, from my local computer has an IP address 192.168, right? That's a private IP address. And this is a different IP address. It's actually trying to communicate from my local computer to the Kubernetes cluster. And this is a pod, right? Actually, it's trying to talk to this particular specified pod, which is actually running MongoDB and listening on this port, right? So this is what port forward does. It creates a tunnel and forwards all of your traffic that comes to this particular address to your Kubernetes cluster. Is basically communication is two-way, so to and from. So let's say I'm sending a request, a HTTP request, so it's gonna send you back the response to this client, right? So this is what exactly it does. So we're gonna see that in practice. So kubectl and port forward, and let's say we talk about the service, and service is basically listening on, if you have remembered, the service is basically listening on this particular port, right? So you're gonna copy this. This is what you can also see it running as vc command, right? And let me show it to you. So what I'm going to do right now, if I'm saying this, it means that I'm telling, hey, I do not want to specify a particular port. Let's say here, I talked about this port. Now I'm telling that, hey, I do not have a choice of port. So give me a random port. So right now, it's going to give me a random port. Let me see how this works. So actually, look at this. It's actually giving me a random port. So if I'm trying to access this service, let me go here. Look at this. So now let me make it a little bigger. So now actually I got a response back. And you can see the handling connection for this one, right? And if I access this service on this port, on this particular port, is actually talking behind the hood to my Kubernetes pod, which is actually exposed right here, right? So from my local computer, it's actually talking to Kubernetes cluster, right? So why actually do you need this? Maybe let's say you have use cases where you do not want to expose your Kubernetes cluster for outsider. For debugging purposes, for testing purposes, you could do port forward. And this is how you could actually expose your service and you can test out things, right? You can experiment things. So you can see this is the response I get back in return. So what happens, let's say I cancel this, right? And this time, instead of this, let me talk about port 7000. This time, if I'm trying to do this, it says that unable to listen on port. Actually, this address is already is in use. I might have something else actually running on that port, so which is why it's not. So you need to basically make sure that you close the connection. All right. So actually, it is here, I believe. Yeah, I think it's here. Most likely. Yeah, you can see this is where my connection were open. That's why it was not working. So let me go back because I have. Now this time it's working because I did not remember that I had something else actually running on there. So if I'm trying to access this time, you can say I can still access the service, right? What happens if I try to do something else? So this time, let's say I want to say port 5000 and then 27017, and I also want to say 8000 27017. Is this possible? Yes, it's possible. You are doing 1-1 mapping, meaning that this time you have opened up 3 different ports on your local computer. I'm talking about on my Mac, right? So 7000, 5000, 8000. So 8000 is mapped to the port number where my service is actually listening to. If I run this, it's gonna still work. So if I'm going to now 8000, I try to access the service, still I'm actually able to access the service. So this is what you could actually do. So what happens if I'm trying to do something else? Let's say this time I'm trying to do something else like this. Let's say I just say 27017. I think that's the port number, right? So if you are trying to do this time, what happens? Look at this. Opening up this particular port, let me go there, right? This particular port, and it is actually mapped to the specified port, which is where basically the service is actually exposed, right? So if I cancel this time I want to do something else. Let's say I say 7000. So this time you can see it doesn't have a port, right? It's not listening on that particular port. It is actually listening on this particular port. So therefore, it doesn't know how to actually talk to, right? So you see the difference. But if you're saying something like this is gonna work because now this is the port on your local computer, the left hand side, and the right hand side is basically the port where my service is running on the container side, right? So this is why if you pass this, it doesn't actually work, it works. Now I want to show you something else. Let's say this time I want to say bind address because this is something you can actually do. So in this case, I can say localhost. Remember, if you want to specify particular IP address, you could actually do so. So let's say you have a particular IP address 192.168 blah blah blah, you can actually do so. And every time you pass an IP address, you put a comma. But in our case, if you remember, we pass this one, bind IP of this. So it's basically gonna listen to anything, literally. we don't really need this. So if you want to say this is what you can do, because any IP address is on your network, or you can say specific IP address, let's say 10.10.10. And this specific IP address is basically, I'm talking about my private IP address. So this is what is not going to be able to listen, because this is what actually doesn't exist on my private IP address. So remember that. So this is what is basically port forward, right? So you can expose your service from outside of the cluster for testing purposes, for any other purposes, like on a particular port on the local computer. So this is what exactly is doing. So let me show you something else. Let's say this time our service is basically listening on this one, right? So what happens if I actually try to talk to Mongo? So let's say I have got Mongo SH. You need to install this if you do not have it installed. So this time, if you see, the service is actually listening on port 7000 on my local computer. So this time I'm going to talk to Mongo, and straight you can see I can access the service without going into the Kubernetes cluster. I'm actually able to access MongoDB. You can see MongoDB, which is running within my Kubernetes cluster, because I have the port forwarded, right? So now, as long as this is open, you can talk to. So this is a temporary connection opening, as you can see. So if I close this and I try to do something now here, you can see, so if I say show DBs, this is not gonna work. You see, the connection is interrupted because it doesn't know how to talk to. It means that my computer doesn't know how to talk to your Kubernetes cluster. So now if I am actually running this one more time, and this time actually I say show DBs, you can see it shows the list of DBs that is available. These are basically the by default. For example, if you want to do something more, you can just always go to help, actually help. It is going to show you a lot of the options that you could actually do. So you can see show profile, show users, and blah blah. So many things you can do. You can show table, things like that. So anyway, so use admin and show tables. Yeah, show roles maybe I can do, right? We so far talked about port forwarding of the service. Now we're gonna do actually kubectl and port forward. This time we're gonna do the port forwarding for the pod. Okay, so 27017, this is where the service was exposed to. So this time we got the random IP address, right? And on the right hand side I have this. Do the port forwarding for this particular pod, we can actually access the service, right? So you're gonna kill and gonna try the other one. So this time port forwarding we're gonna do for kubectl port forward, and we're gonna do for replica sets. So replica sets by default you can see is Mongo is coming. So this time we're gonna do again, we're gonna put the random port instead of specifying it. If I'm trying to do this time again, this port number is different, right? Because it's randomly chosen. So again, you can see you can access the service. If I'm killing this and trying the other option, kubectl port forward, this time we're gonna do deployment, and deployment is basically Mongo, right? And we're gonna say 27017, and still we're gonna be able to access the service. So let's see if I'm going here, trying this still. So we did port forwarding for deployments, we did port forwarding for replica sets, we did port forwarding for the pod, and throughout the whole video we talked about port forwarding, deployments. Instead of deployments, we're gonna say service is Mongo, and this time we're gonna say the port number. So still this is actually working, as you can see. So we did put forward for the services, for the deployments, for the replica sets, for the ports, like 1, 2, 3, 4 different types we tried, and we are still able to access the service. So I hope you understand the concept of port forwarding. This is how actually you can access your service without actually going into Kubernetes cluster using a port forward. So this is what was the purpose of today's video. I hope you understand the concept of port forward and you know basically how to access your service from your local computer without exposing your Kubernetes cluster publicly. But the main point of this video is to walk you through with Kubernetes Dashboard. So particularly, why should you be actually using Dashboard? What could you do actually with the dashboard, right? So first of all, let me show you Minikube add-ons list. In Minikube, I talked about this stuff in my previous videos. So you can see add-on, you can say plugins. This dashboard is not by default enabled. So as you can see, that dashboard is disabled and it is actually maintained by Kubernetes. So what Minikube actually did, they did integrate with Kubernetes dashboard, right? And this is what actually you could do. So Minikube, add-ons, enable, and if I'm saying dashboard, this is what it's going to do. So then one more thing I'm going to do later on in the videos, but not in today's videos. Let's skip this one because we are not going to talk about this. Minikube dashboard is actually enabled, as you can see. So if I'm going to run Minikube, let me clear this. Add-on, list, grep, dashboard. This time I can see the dashboard is actually enabled, right? So now we have enabled dashboard, and before we actually jump a bit further, I'm going to tell you what could you actually do using Minikube dashboard. So this is what actually you could do. You could deploy your containerized application to your Kubernetes cluster. So Kubernetes cluster is basically, this is what we have. Minikube, and if I say status, we are actually using 2 nodes Minikube cluster, okay? And these nodes are actually running on Docker container. You can troubleshoot your containerized application. Let's say something goes wrong. You could go to the dashboard. Dashboard is basically nothing, just the web interface, okay? And there you can have the holistic view, the overall view of your entire Kubernetes cluster. So you can basically see what you could see using the CLI commands, right? Then you could basically manage your Kubernetes resources. How to do that? We're gonna show it to you in a bit. First of all, I just wanted to give you an introduction. As I said, you can get overview of your application running on your Kubernetes cluster, right? And you can do a lot of things. You can create things, you can delete things, you can update things. For example, your deployments, pod services, jobs, daemon set, and whatnot. So this is what basically you can do using Kubernetes dashboard. And if you're asking me, hey, is this something you actually use at work? To be honest, I never used it, but this is good for learning. So if you're learning Kubernetes, if you're new to this, new to the realm of Kubernetes, this is a very good starting point for you because you're gonna see from the web interface what are the things actually comes with Kubernetes dashboard. What are the things actually you could do, right? Apart from that, you could do much more. For example, scaling your deployment. You could initiate rolling update. You can restart pod, right? You could do new deployment for your application, right? Using the web interface. If you have not understood yet, it's not a problem because we're going to do the demo. So you're going to understand everything when you see the things in front of your eyes, right? So you're going to say Minikube. Let me jump into the business. Minikube dashboard, and this dashboard has couple of options. So you can see URL, display dashboard URL instead of opening a browser. By default, it is actually false. So what we're gonna do, these are the options you could actually go with. So expose port of proxy dashboard, set to 0 to pick a random port, right? So this is what we're gonna do, Minikube dashboard. And then after that, I'm going to run the command called URL that you have just seen, right? The option URL. So if I do this, let's see what happens. Look at this. This is HTTPS Kubernetes dashboard proxy. So it basically does the proxy. So what we're going to do is basically, let's say I copy the whole thing and I go to my browser. Let me go to DuckDuckGo. And if I jump in here, you can see I see the dashboard of Kubernetes, and this is what actually it looks like. If you have never seen it, first time you access this dashboard, this is how it's gonna look like. So it has a couple of sections like work alerts, service, config and storage, cluster, settings. For example, here you can do a lot of things from the UI, right? So in the first place, let's try to understand the very basic stuff. So I cannot actually go through all of these because these are the basic concepts in Kubernetes. So I'm not going to talk about cron jobs, daemon sets, deployments at this point, jobs, parts. I believe that you understand some of the basics. If you do not understand, maybe you can follow along and you can Google basically what it means and things like that. Along the way, I will try to actually talk about it, but this is not the purpose of this video to go through all of this. If you need more like a longer videos, please let me know. I will try to make one for you guys. So my focus is going to be today on the deployment, parts, replica set, ingress I'm not going to talk about today. That's for the future videos, and services. Because I'm going to stick to my content, because in my previous videos, if you have seen my previous videos, all of these videos actually talked about the things I just talked about right here. So what we have done in our previous videos, don't kill this one. If you kill this one, you are not going to be able to access this dashboard anymore. So I would need one more terminal. I could create one. And if I run this command called kubectl get ports, you would see there is nothing running. And this is why when you come here, it says default. Look at this. This is something I talked about, because get namespace, this is what you're gonna see. Now you can see the Kubernetes dashboard is basically running on this particular namespace. And by default, when you log in, this is what you're gonna see. So you can see namespaces, right? And if you have different resources under different namespaces, you just need to switch, and it's gonna list all the resources that falls under particular namespaces, right? At this point, it's completely empty. There is nothing. So what I'm gonna do, I'm going to show you, because this is something I showed you before. So maybe this is gonna be a good starting point. So if I'm saying that, let me, instead of this, what I'm gonna do is basically here, let's say I try to do a deployment. So you're gonna click on this button, you're gonna say create. There are multiple options. You can see you can create. Let me show you. I could copy this content, and this content is actually taken from my previous video. I could do right here like this, and then I could say this is my input, and let's say you try to upload something, meaning that it's actually trying to, right now it's actually creating the deployment. This was one option. So you could bring your own manifest file, so YAML file, and you could just copy and paste and upload it. So it's gonna create a pod. So now if I'm doing this, kubectl get pods, you're gonna see Mongo, right? This is the one actually it deployed. So if I click here, that's what exactly I'm gonna see, 99h. You're gonna see 99h, right? So that's the pod we just created. So what happens if you're not so happy about this? You could actually do a little bit more stuff here. How? You could edit this stuff. Let's say instead of, let me search replicas, I'm actually in the pod, so I would not be seeing it. If I go to deployments, I would be definitely seeing it. So I'm gonna show it to you in a second. Bear with me. Then you could delete it. So if I delete it, this pod is gonna go away, right? But see what happens. Let me do this. So let's say I deleted this pod, and if I refresh, actually something has happened, but you can see there is 14 seconds, meaning this pod is created 14 seconds before, is because of the deployment. Because the deployment, if you look here, we talked about one replica run all the time. So even though you kill the pod, the deployment actually knows, hey, pod is actually a pod is actually deleted, I need to create one more because I have the condition I have to be running one pod at all time. So now if I'm saying 2, let's say I'm just doing the modification from right here within the UI and I update it, let's see what happens. So this time you're gonna see 2 of them. Look at this, it's saying 2, but right now one is up and running, another one is on the way. So let me go to the pod. You can see this pod is 14 seconds before it actually came, and if I'm deleting this one, it's gonna create again because we said that 2 pods should be running at all times. So actually it started again, right? And interesting part of this one is this exec command, because normally you run this command. If you go to kubectl, then you're gonna see kubectl exec -it pod blah blah and bin bash, right? I'm not gonna show it to you here right now, I'm just focusing on the UI part. You could do this. So let's say if I do exec, right now what has happened, it actually took you to the pod that is running in our Kubernetes cluster. Now if I'm saying Mongo, you can see this gives me the version of Mongo because this pod is actually running MongoDB version 4.2. That's what I talked about in the previous videos. Let's exit. This is what happens. You basically did the exit. Look at this. So if I'm going here to the pod, I'm back to this, and I could go actually see the logs as well. Look at this. So you can see full log for this particular pod, right? This is the pod, right? Now you understand the pod part. Now you understand the options you have. You can edit, delete, exec, and logs, right? So you understand this, how easy it is. And if you need more replicas, let's say now you can see 2, and if you want to restart, if you want to scale, for example, let's say I want to scale. So desired is basically 2. Instead of 2, I'm gonna say 3. Actual replicas right now is 2. You don't have to do anything. So just say desired. So if you say scale, let's see what happens. So this time you can see it has already updated to 3, right? This is what exactly you could do using the kubectl command, kubectl scale, and then you say replicas, right? Replicas 3 and deployment. This is something we talked about in our previous videos, and we're going to talk about Mongo, right? So if I was doing that, let me show it to you since I'm already here. So if I'm saying 4 this time, so this time from the command line I'm saying that, hey, give me 4 replicas, meaning that 4 pods should be running at all time. And if I come back here, you can see this is updated to 4. Excellent. Even if you go back to pods, this is what you're going to see. And if you go to replica set, this is what you're going to see as well, right? Replica set does what? So replica set basically is going to make sure that 4 replicas are running at all time. And here we are not doing anything at this point, so let's skip this because this video is going to be pretty long, so I wanted to keep it a little bit shorter and wanted to align with my previous videos so that you understand basically what I have done so far using kubectl commands, what we are doing right now using the dashboard. So the next part we want to look into is basically you can go to nodes, for example, and you can see 2 nodes, and this is what actual node list, right? This is what exactly we have seen, right? So it gives you the information about the nodes, and here you could do much more. Let's say if you want to delete the node, you could do so. If you want to edit the node and do stuff like that, there is JSON and YAML format. You can do stuff, right? Look at this. So you can modify any other things here and then just say update. As simple as that, right? So now we understand the basic part of it. And if you want to, let's say, create more nodes, you could actually do so as well. Oh, here is one thing I forgot. Now it came back here. There is one thing I didn't actually show it to you, is here. So next one is create from file. Let's say I have this file. This is from another branch. You could actually do that as well. You come to this particular location, right? Wherever this file exists, then you could actually upload it. This is another way. The third way is the easiest way. So you're gonna name, like, let's say if I'm calling Nginx, I just want to fill this up and show it to you. And this is like Nginx image coming from, let's say, Nginx image, let's say coming from docker.io, right? Number of ports, how many you want, let's say 1. Service, in this case you can say internal or external. Let's say I want to say it external, and you can say the port, let's say port 9000, target port less than 9000, and this is basically TCP, right? And the other thing you could do, which namespace actually want to deploy. So this is another way of doing it. So I'm going to cancel it. You understand the concept, right? And if you are going for the advanced option, this is exactly, I'm going to show you. This is exactly you can do, like the resource limits, right? So if you look at here, it gives you the CPU requirements, memory requirements, right? You can run particular commands, whether you want to run it as a privileged one or not, and you want to run some environment variables or not. This is what all you could do using the user interface, right? So this is really super cool. You just need to fill up the information, and if you do not know how to do it, you can follow my videos as well. So these are basically filling up the information, nothing else you have to do. As simple as that. I'm not actually filling up at this point. I believe that you get the concept and you should be able to do this because it's very basic. You just need to fill up the information and it's nothing complex, right? So I'm not going to do that at this point. I'm going to skip. Second thing, you want to, let's say, unsaved changes. Yes, let's go ahead from here. Let's see if we have any secrets or not. Let's see if we have any, because it's basically empty, because as I said, there is nothing in our Kubernetes cluster, right? Jobs, we don't really have. Daemon sets, we don't really have anything, right? Role bindings, we don't really have anything. Roles, no, nothing. Like, it's totally empty. So now let us create a service. We have the deployment, right? And what do we want to do? We want to create a service. So for the service creation, I'm gonna go ahead the same way I did for the deployment. So I'm gonna grab this particular file, right? The manifest file that we have. After that, I'm going to paste it right here. And if I say upload, it's going to create the cluster service type cluster IP. Okay, as you can see, this is the cluster IP service type it is created. And if you want to change anything, you can always go ahead and go to this particular section and you can just edit anything that you want. So if I run this command, let's say right here, I want to create one more tab, kubectl get svc. I'm gonna see there is the service called Mongo and it has this cluster IP, right? And this is the port. So this service is internally exposed, meaning that this service is not public. This is only accessible internally, unless you do port forwarding, some kind of networking like tunneling, for example. Alright, so we created the service, right? If you're writing this, it's gonna straight open up on your browser. If you're writing Minikube Dashboard, right? This is what going to open up the proxy, and then look at this. This does it by itself. So basically accessing the service using your default browser. So this is what it looks like because we do not have much stuff. We have a deployment, we have a pod running, and we have one replica set. And the one we are interested in right now is the service called Mongo, right? And this is the internal endpoints, and there is currently no external endpoints. And if you want to edit, you can look into this one. For example, this is a cluster type. If you want to make it to load balancer, for example, you could do that as well. So you can just say load balancer, something like this, right? If you want to make it to node port, you can make it node port. But for us, we are fine with the cluster IP. Okay, so I'm gonna cancel this. So we have the cluster IP, meaning that the service is not going to be exposed outside of the Kubernetes cluster, right? So what we're gonna do in Minikube, you could do this. So let me open up a new tab and let's call it Minikube service list. I have showed this stuff in my previous videos, therefore I'm not going to explain to you in details right now. So this is the one we have. So kube, cdl, get, svc, mongo, and this is what we have, as you can see, right? And this is the port in Mongo that we are using, right? So what we're gonna do this time, we're gonna run Minikube. Let me clear this up, service, and this time we're gonna call Mongo. And if we do this, you can see we are able to actually access the service. What it does, it actually, look at this. I talked about it before, starting tunnel for service Mongo. Minikube will, behind the hood, will start a tunnel so that the traffic from my computer, so I'm talking about the client, to all the way to Kubernetes cluster. Kubernetes cluster, remember, is running on a different network from my computer network, right? From here, you can see randomly it has selected a port right here, right? And it is actually, this is the address, is actually routing the traffic to and from this computer to our Kubernetes cluster. So the Kubernetes cluster is basically Minikube cluster. So this is how you can do stuff using the Kubernetes dashboard. In the future, we'll be talking more about other options as well as we progress in this series of Kubernetes videos. But for now, I'm gonna keep this video until this, and in the next, we'll be talking about something different. If you like this video and find it useful, do not forget to give it a thumbs up. Share the content with your friends and colleagues if this is something useful. So I will see you guys in another videos, and until then, stay tuned and cheers everyone. Bye bye.